Hello everyone who's watching us. Thanks for joining. And first of all, I would like to thank Advait for setting up the context. Now I think we can go forward looking what we have done in this quantum AI domain. So when and how can I start using quantum AI? That's a very basic question which one can ask. So the simple thing is, in about 30 minutes, maybe less than that, you will learn how can you use quantum AI with a software that is Quant Pracar. So Quant Pracar will be available to you. All you have to do is, in this description box, there's a link available. You can just press on that link and you can go fill out the form and you will receive a copy of Quant Pracar from our end. So without further ado, I think we should move on to the next part. So yeah, now the product is out there, product is launched by us. So the Quant Pracar is the name of the product. What it does is basically, you can use it for the quantum AI purpose. So again, there are various classical algorithms that are out there. So like those, we have quantum AI algorithm as well, right? So you can see over here, SVC, ANN are the classical approaches, whereas the QSVC and QNN are the quantum approach to these algorithms. So you can train your model and you can use it for the prediction purpose. You can hyper tune your parameter and you can build more and more robust model using the software. Quantum circuit visualization is also something which you can do. We will see all this just in few minutes. So yeah, so a dedicated prediction window is also available, so you can use that too. Moving forward, we see this is a graphical user interface for Quant Pracar. On the upper left corner, there's a Quant Pracar logo which is present over there. This is the logo. Here you can see the flow chart. Now this flow chart is nothing but a representation where are you at the current moment while doing the operation. You will learn frequently in a minute, okay? And below you can see the navigation bar. Navigation bar is nothing but it will tell you which part you are at the moment, okay? Basically, if you want to train your model, you can click on this button over here. And if you want to go to the prediction window, there's a separate button. We'll see that in the demo once again. So I'll tell you what the workflow is. It's start basically an idea. Whatever the project, whatever the data, if you have, you want to analyze the data, you want to grasp good insights from it. Okay. So all you have to do is you have to upload the data in Quant Pracar. What it will do is it will process the data. Then you can select the algorithm. If you are using a quantum approach, you have to select the feature map, right? And then after tuning the hyperparameter, you can train your model. So if you are happy with the results after evaluation, so you can go forward and you can use that model. If not, you can go back and you can do again. You can again basically tune your hyperparameters, and then you can do this process until you get your desired result. Okay, so yeah, I think Advait has already covered this, that algorithm that currently we have, the classical and the quantum AI. This is something which I've already mentioned to you, right? So next part is visualization as well. So it provides visualization feature as well, where you can see the quantum circuit and the loss function after your training. Okay, so what I've done is I've taken a case study. Okay, so what the case study is, I'll tell you in a brief about it. So there's a data set of around, I think, more than 1,000 blocks of concrete. So what we have done is we have made a concrete out of all these components using different proportion of these for sure. So we have cement, we have blast furnace slag in the data set. We have fly ash, water, super plasticizer, codes and fine aggregates. All these data sets we have, and again, yeah, the age is also there. So all these parameters we have used to predict the concrete strength. So this is a experimental data that has been done. What we will do now is we will train our model using this case study, and at the end we'll do a prediction for this particular concrete block, which we have made using cement, these configuration of cement, blast furnace, fly ash, water, right? With these quantity, we'll do the prediction of the strength. Okay, I think now it's a time we should go to have a quick demo. So here is the software. You can see, as mentioned earlier, this is the window. This is a home page basically. Here we have a train model button, and then we have a prediction button if we want to do the prediction part. So first, as we don't have any model yet prepared, so we'll go to train and we'll train our model. So you might have observed that this part has become black, so it means that you are in the next stage. This yellow color over here, it's showing us the progress over the time. So we'll give a name to this project. Let's say concrete strength project. Okay, so we are creating, we have to create a file. Okay, just a second. Now we have to save a data. I'm saving this in the same file in dist. Yeah, I've selected a directory where I want to save this project. Now next part is I have to upload the data set. So I have my data set in this part. So here we have a concrete data set, and I will select this data set and I've opened that. Okay, next step is I want to select algorithm. Which algorithm? I think before I go forward, I should also showcase you what the data set actually look like, right? So this is a concrete data set. So yeah, for all these different quantity of cement, blast furnace, fly ash, as mentioned, I have the experimental strength from experimental result basically. Okay, now as I have selected that, I've selected the part to data set. Now I will go for algorithm. So what I'm doing is I'm selecting the quantum algorithm, that to quantum neural network. Okay, now I will save and proceed this. Okay, now in this step I have to mention which feature map do I need to select, whether ZZ or Z feature map. So I'm going with the ZZ feature map. Next is the hyperparameter page. So on this basically this is a page where you can change various things, whether what is the test size that you want to give. So here I've taken 20%. You have to initialize the random state as or whatever you want, right? Entanglement, which we can give here. You want linear, circular, full, right? Epoch, suppose I'm giving 500 epochs, right? And learning rate, number of folds, how many folds you want to give. Okay, suppose I'm giving it 3 folds. Next is optimizer. Adam is best so far, so I'm going with that only. And then the number of neurons in the first layer. All these data, I have to save this. Then only I can go to summary report. Now, what does the summary report showcase is all the material that you have, all the parameter that you have selected. So here it's showing you a crisp short summary to that. So just for a last check, if you think that anything is wrong, you can go back and you can change that again. Okay. Once you're done with this, you can simply press the train button and this is blue. That means training is happening. So at the same time, I want to mention that terminal is also there, right? And terminal, you will see the progress. So we can see that for first, it's first fold, it'll go for 500 epochs. So similarly, I've taken 3 folds, right? So we can see that the pace at which it's happening is fast because the data is simple CSV format data. So training is happening quite fast. So after every fold, it's also calculating the test loss also, right? So we have to wait until, so yeah, it's only, we have only selected 3 folds at this time. So after the 500th epoch of this, it will be finished. Training will be done. Yeah. So what we can see here, we can see after the training is completed, it's showing us the average loss, average training accuracy or loss, right? It's showing us the time it took to train this model. It is showing what sort of task you have given, whether it is a regression or the classification task, right? And after that, it has done the evaluation part also. So these are as these are being done, what we can do is we can minimize this part and we can go to the evaluate model. Now in this evaluate model, what we see is the performance, right? We see the loss metrics. What we see is this the epochs versus loss curve, that as we have increased the number of epochs, the loss is also become, because the loss is also reduced, right? Along with this, what we are getting is the quantum circuit also, right? We are also getting the quantum circuit. It's mentioning over here whether which feature map you have selected, ZZ or Z, right? So it is mentioned. And then once this is done, that means you have done the training, you've got the, I know that this loss is 45, it's not a good number. But again, if you want to improve this, what you can do is you can go back, you can change the hyperparameter, you can train again unless you get the best result, right? So now we are done with this training part. What we can go towards directly to the prediction. Okay. So now I want to mention one thing. Now look, entire thing is black. Only this part is colorful. That means we are at the prediction window. So very first part is we have to select which algorithm again, as it is QNN, and if it is a ZZ feature map, you have to mention entanglement also. So I've selected linear because I have given linear in my original set. Okay. Now the next thing is we have to upload the model, right? So look, first I'll showcase you all the thing which we have created. So this is the project that we have created, right? So here our model is being saved. Once our training is done, model is saved. Along with this, we have a summary report as well as the performance data. Whatever the parameters you have given, that is also being saved, and the pre-processed data is also here, is also saved. Okay. Now we can use our model directly from here for the prediction purposes. So what I'm doing is I'm going, just a second. Yeah, this is a Quant Pracar. I'm going to project, and from here I can select model.pkl. That's a model file. Now input data set. Now I hope you remember that here I said that on these, after training a model, we'll check whether on these parameters I'm getting good strength or not, right? So I will input the data. So data I've saved here only, this X part basically. I can show you that too. So yeah, these are the parameters basically. Cement value is 380, blast furnace 95, fly ash is 0, water 228. These are the same as mentioned in the slide, right? So once I've selected the data also, all you have to do is I have to press on prediction button, and what I see is prediction is done. So to check our prediction, what we have to do is we have to go to our project, and here we can see that this prediction CSV file, and what we see is it's coming as 39.85, right? Now I do have the original data also for this. So in actual, basically for the same parameter, I see for the same parameter the strength was 39, and with a prediction it is coming a little more than 39, which is actually pretty good comparing to the loss that we had. It's actually pretty good. So yeah, you can see how robust the nature is, right? Yeah, so that's all about it, about Quant Pracar. How you can this is about end-to-end process, like how you can begin your project and all. Again, there are various algorithms. We have classical SVC, artificial neural network also, which are quite simple. And then we have QSVC also, where again we give user a chance to select which feature map they want, which sort of approach they are looking for, all these things. And then they can again select from here what sort of test size they're looking for, what sort of entanglement they're looking for, right? So I think you can use in various ways, in whatever the data you have, whatever the industry you belong to, you can use that data to make prediction, and you might get some useful result. Yeah, so that's all about the Quant Pracar. Let me minimize this. Just a second, it's not coming. I think like that's the end for Quant Pracar. So again, I want to mention, if you find it useful, so there's a link in the description box. You should totally go to that link, and you have to give few information, and then we will be emailing you, email and name, that sort of information that will be required, and then we will be emailing you the product, so you can make use out of it in your daily life. Yeah, so that's all about Quant Pracar. Now I think I would like to end it with this very small yet very powerful quotation by Paul Dirac. Like, pick a flower on earth and you move the farthest star. So it speaks about, I think, entanglement. So which in itself, like, this is such a short line yet so much powerful. These are the people who keeps us motivated in what we are doing, right? Yeah, thanks for now. And what I can say is, like, if you want further update from our end, you should totally definitely you should follow us on, you should subscribe us first of all on YouTube, and you should definitely go check out our website. There we have a section for Quant Pracar also, so you can go to that. There also the form is provided. I don't know why this slide is not opening. I'm checking. Here basically I have provided the QR code. No worries. I'll do one thing. I'll talk to my team. We will be sharing you. We'll be sharing you the link. Just fill out the form and we'll get back to you. So for now, I think that's all from our end. Thanks for joining, first of all. Thanks to all of you from different part of the world. I see you have joined, and yeah, I see the enthusiasm. It is very much appreciated. We are also very much working into it. So in future, if something comes up, we'll definitely get back to you.